Hello, my name is Stephen Brennan, and I'm here for Excel Report 2. For the medications of half-life, we dealt with ibuprofen, and the other three that I chose are caffeine, Adderall, and aspirin. I just picked them out of the whim, no reason. Well, caffeine I chose specifically because I was just pretty much curious, but as we can see, they're pretty much all the same. They well, obviously Half-Life does the same thing, but depending on the quantity, I mean, it's basically the same graph. It just starts on the top and just goes down. Exponential curve, of course. It's a Half-Life. We're dealing with the same like ratio of it decreasing and then plateauing. Um, yeah. And for the report, how many times can you divide a number? Well, the same amount of times you can multiply a number infinitely. Doesn't really matter. It's just like matter. Speaking of matter, it's just like matter in the universe. It can't be destroyed. Same with this. You can't divide a number enough till it becomes nothing. That's just not a thing. And the asymptote, the line that continuously approaches a given curve and does not meet a finite distance, is proof of that. It just gets closer and closer, but it never quite reaches it. So, with that logic, ibuprofen never really leaves our body necessarily. Even though, or no, I think we shortened that one. Yeah, that's 0 because Excel made that 0. No matter what, it's technically still in our body, I guess. That's kind of a weird thought to me that I don't like. And the letter E in these equations is a rational number just like pi. The number or letter E, whatever you want to call it, is related to the slope of the exponential function of all the graphs and the curves we see here, and which our trend line becomes and basically follows it, and we can't really see that trend line because it's just so close to the actual line. So on this one, you can barely even see the trend line. You see a little thickness in there. I mean, but even all the others are pretty much indistinguishable. Oh, that one's you can actually see separate from the line. But for the most part, you can't really see them. And the reason we have the treadline forum in all these is it's just the math. It gives us the math reason for the curve. It shows us how it did it and to do it for this specific one. Of course, each one they're a little different depending on the hours and the milligrams. And reasons to even want to know how to calculate half-life well, for me personally, I would like to know what's in my body if I'm taking medication, especially medication I'm not familiar with. Like my dad, he takes 800 milligrams of ibuprofen. Uh, I think he takes about 3 a day. Of course, he separates that within the day, but I still can't imagine it's good. And as we can see here, a decent amount of that ibuprofen is still in his body. Like, let's say he takes it like every 4 hours or something. Then he still has a decent amount of milligrams in his body that he's just adding on top of that. And I can't imagine that's too good. Now for number 2, GM crops and health in America. For the most part, I trust the data. I just don't agree with the connections it's making. But I have nothing wrong with the data itself because I think it's from a government website, I believe correctly. And most of the times that's pretty accurate. And as we can see here, we with the given data, we made graphs, of course, like we do in Excel, about crops grown in the U.S. and its connections to disability? Nah, not disabilities. Health risks. Like I think one was arthritis. Yeah, diagnosed bowel disease. I was not going to look that one up. But as we can see, the acres. Wait, which one? Yeah, okay, it's this one. The acres on all these blue lines, except this one. This one was orange. It's all the same data. It's uh, it's all the crops grown, and the orange line or the bars here is the correlation of the, I don't know what to call it, the topic of discussion for that graph and how it correlates. Oh, I forgot to edit that data so it looks better. There, doesn't that make better? Or make better. Doesn't that look better? I changed the x-axis so it's actually even compared to all these. And another interesting thing about these graphs were the secondary uh, x-axis, y-axis. I keep saying that, y-axis, because it's showing different two. It's basically we're taking two line graphs and just overlaying them on top of each other. Like it's still going in the same direction, but the values are different. But yeah, that's just a way to interpret that on one graph, so you wouldn't have to make two graphs. I mean, it's just better and more convenient. That's why we use graphs. It's pretty inconvenient and convenient. That sounded like inconvenient and convenient. And the differences between correlation and causation. Correlation is the statistical measure that indicates the extent to which two or more values fluctuate together, where causation is the action of causing something or the relation between cause and effect. If we confuse them, we will get the wrong idea and misconstrue the data. It's very important that we know the distinction between the two. And with the given data, we can assume that there is a connection. That, I mean, we're seeing this same stat, the acres of corn, GMO corn, or BT corn, whatever, in the millions of acres, and it's equally as much as these specific, in this case, arthritis. It seems to be that the increase of arthritis is corn. You can relate the two. And I kind of don't. I mean, I understand what they're getting at, but I never like doing that because you're just taking two seemingly random facts and you're just saying that there's a connection somewhere. And as I get to in question 5, it's a lot like anti-vaxxers and what they do. They just take information and they just make a connection in their head. They see two different sets of data and they see it that it's correlating with each other. It's pretty even, so they just make a mindless connection. And I mean, yes, it's hard to argue with that, but in my opinion, it's also hard to argue for it also. And for example, the difference between the two reports where we got this information, the FDA acknowledges looking at one thing and seeing a correlation does not mean there's a connection with the other report, which full-heartedly agrees that there is an undoubtable connection. The FDA, government organization, does not see a correlation. And frankly, I don't either. And we can infer it as explain how we can get better access to food. We can infer that is inherently good for you, like fruits. Like we can know generally what's good for you. Pizza every day isn't good for you, for example. I'm just giving a clear cut example there. And I just find it weird that people make connections, and it's no offense to you, it's just I see this all the time. People always make connections, and I understand there's a large community out there that does believe GMOs cause stuff like this, but that anti-vaxxers believe the same thing, and they're pretty much the same size group there. And now because of that, measles are back. A disease we thought was dead for, I don't know, the past century, and it's back because some parents refuse to vaccinate their kids. And more importantly, but nah, never mind. That's off topic. Anyway, report number 3. Ah, yes, impaired driving. In this one, we looked at well, impaired driving and the fatalities of impaired driving through presumably alcohol and other substances. And then this is the fatalities per year right here. And then we take that further and we put it into subsections like gender, location, what kind of vehicle it was, bike. Wait, what kind of person the driver was, age groups, and level of urbanization. And pretty much, for the most part, it's on the decline. And then down here, we made a Venn diagram, or copied a Venn diagram of substances that were found in the body of people who died in car accidents. I think that's correct. And of course, alcohol, cannabis, other miscellaneous drugs, and what's that? Just medications. And we just see how that mixes and matches with everything and what overlaps. And this is everybody, 0.2%. Everybody mixed together. So they were having a fun time. But yeah. And how much you need to drink to get your blood level, alcohol blood content level, to is 0.08. Well, I want to know, so I did have to use the web. It said the general rule of thumb, it takes about 3 drinks an hour for a woman, and it takes about 4 drinks for a man. But of course, it all depends on size and weight. It's just something you can't really quantify with the quantity of beers, which that themselves can be multiple sizes and ounces and such. And it's quite obvious, the higher the blood level, the slower your reaction time gets. Who would have guessed? I wonder why all these car accidents happen. Oh, and then of course back to the Venn diagram, the probability of these percentages, the probability of if you're impaired, I think it was British or the British Isles, whatever, what have you. This is the graph they made that they said would be of the probability of, I'm assuming, can't believe I don't remember. I believe this is the percentage of people they found who have died in a car accident, and like 9% of them were under the influence of alcohol. But then if we look at this, that's not just 9% under alcohol, it's also all these, just with a mixture of other drugs, medication, and cannabis. And driverless cars, interesting topic. Driverless cars will save thousands of lives, and I'm 100% all for it. But it brings up an ethical dilemma that let me just say this. Organ donors, most of the organs people are waiting for, most of them come from car wrecks. Like a good chunk, like 90% of them. I just pulled that number out of the air, but I know it's a massive chunk. So if we all switch driverless cars, which once again I'm all for, but it's just less deaths in that fashion mean less organs for people waiting for them. And it's just an interesting ethical debate that you could say. But once again, I'm all for driverless cars. It will make the road safer, and everything would go faster if everything was connected like that. And I'm not one of those people who are paranoid. Oh, AI is going to take over. Yeah, okay. We're kind of a few decades away from that, so I think we're fine with driverless cars. Number 4, we looked at the percentages in age group and year of people texting and driving, or more accurately, using handheld, being distracted by a cell phone. And we divided that in age groups, and this is just the chart itself based on the year. And pretty well, as time progresses, people are getting a little bit more common sense, and it's so steadily going down. I mean, plus that's a stupid way to die. Just saying. And these we dissected them in. We went further and dissected them into more. What's the word? What's the word I'm looking for? We're just taking a better look at the specific data. In this, it's the same graph with the trend line there, the box and Lister plot, and the what do you call it? Bell-shaped curve, distribution curve. And we did that for all the age groups, for 25 through 65 and 70 plus. And the first one was 16 and 24. And to comment on the vertical axes, before I changed all these, it assumed it just wanted to zoom and look on this, like, let's say this, I'm pointing at the screen, the box and whisker plot, it was super zoomed in. And we can't really do anything with that, and we had to make it all even, because out before it basically looked like it had an outlier or something. And yeah, I'm pretty sure it was super zoomed in on the 70 plus, and it looked like it was kind of going up to an extent. But with all these set to 1% each y-axis point, it went up to 10%, and we did that for the same. Because if they're different, you can't really take them at face value. And that's the point of a graph, is to take them at face value so you can actually use it for whatever you're doing. Even just understanding the data. You don't want to have misinformation. We already talked about that in Report 1. And an outlier is a pretty simple, easy to understand thing. If I take this and just throw in a huge number. Wait, what? Oh, okay. Wait, what? Okay, maybe I changed it too much. Oh no, never mind. Yeah, that's the curve. It's just I have to zoom in, really zoom out a lot. Okay, maybe that was too much of an outlier. Let me decrease that a little bit. There we go, a more down-to-earth one. I changed it to 50 instead of 200. And as we can see, an outlier, it destroys the information. The trend line, which I always interpreted as basically the average line, because we have one at 50%, which is all the way up here that we can't see in the graph, it's making it come down with the average of all this other data. And of course, outlier, you can't trust a graph with an outlier, of course, because it's just false information at that point. Or not false, but it's very rare that you would have something with these small percentages and then have one that's 50% like that. Very rare. Okay, let me undo that. And with the link you showed us, both data sources seem to be similar, with fatal car crashes generally decreasing, and with the 70 plus group still staying about the same, just fluctuating just a little bit, not really taking sides there. And that's a good way to know, for me at least, that your source is correct. If you're getting two different sources and they're telling you basically the same thing, then yeah, you got a pretty safe bet that you can trust that source. And I would use it for information. In the distribution of wealth, we just took data and we could see that a percentage of get that light out of the camera, a percentage of the percentage of people in the US own basically all the wealth. Surprise, surprise. And I even scroll down, and that's exactly what I wrote down a couple days ago. Surprise, surprise. And the percentage of the amount of money, yeah, they got most of it. And we can't really distribute the money evenly, because if we did, it would just hurt the economy if everybody was equal in an economic sense. Uh, Plus, also, it's kind of you're kind of leading into socialist territory there. Just saying. And the rich are basically the outliers of our economy. I mean, everybody else is pretty much the same, but then when you get to that little bit of percentage, it goes way up. And our federal taxes, where they go, is represented in this pie chart. I'm really surprised how much money actually goes to Social Security specifically. In defense, I'm not really surprised about that. Do I think that's needed? No, but I'm not surprised by that. And of course, only 2% goes to education, of course. But let's not talk about that specifically. At least my personal feelings on that. And from what I found in the state income, most of our state income taxes seems to be spent more on sales and gross recipients. I don't really know what that means, but it's at 4.5 million. So should probably do some more research and find out what that is, because I have no idea what that is. And this is an easy one. If we didn't have a tax system, our economy would not be stable at all. It would, if we even would have an economy at that point. No taxes mean no governments, no regulations, no rules, no laws. It'd be the definition of chaos. It would not turn well. I mean, there's a rare chance we could evolve and reformat laws, but I find it very unlikely, and the whole world would just collapse. Whoa! Oh, hold on. Kind of messed that up. And then this was a fun one, paying taxes. In this one, we just looked at how you file your taxes and how it would be worth it to accept a raise or not. And for head of household case, it was not, because the leftover amount was not good. It was lower than before, because once you pass that threshold for the type of thing he filed for, it goes down. I mean, unless you got like a $4,000 raise instead of a $2,000 range, then maybe it would be worth it. Actually, no. Looking at this, it would not. It'd probably have to be like an $8,000 raise for it to even be worth it. Make a little bit of extra money. And you can decide whether to get a raise is worth it by doing what we just did up here, doing your research, looking at a federal, state, how much they take, how much federal takes, what you're filing for, taking all these into account. It's just very important. Just do your own research. And honestly, it's not that hard, especially if we already have a format like this to refer to if we ever need to do it ourselves. And depending on how you file, the general percentage it takes from you is different. That's why when a head of household filed, he got less, where the raise actually mattered to them. If you're married or single right here, or when you were head of household, it just wasn't. It's just the percentage the government will take from you, and by just passing that next threshold, it would hurt you in the case of head of household, but in single and married filing, it was fine, or it is fine. And if I was to change the taxes myself, I would say the stereotypical tax rich, but as we've seen throughout history, that doesn't really equate to anything since they get out of it no matter what. So honestly, if I had to change the taxes, I'd probably keep it the same. I mean, we could try to tax the rich, but it would not turn out well. I mean, just look at Apple, an American company, but they don't have to pay. They don't have to pay the U.S. taxes at all. At least, I mean, their annual taxes, probably property tax and stuff like that. But that's just the small fry stuff. They don't have to pay taxes to the U.S. because they're stationed. They're an Irish company, in case you didn't know. And that's because in Ireland, the taxes are insanely low. And they're insanely low because Ireland wants all those companies to be based in there. And I'm pretty sure Facebook is based in there. I could be misremembering, but I know a lot of companies are there, and I know Apple is there. So Apple isn't even an American company in the eyes of the law. It is 100% an Irish company because it is based in Ireland because of how they file their taxes. So that's a little good piece of trivia for you. Well, I think that's it. So see you next Monday.